Dear, dear colleagues, dear friends, dear participants, smart cables are a revolutionary initiative that integrates environmental sensors into submarine telecommunication cables, enhancing ocean monitoring and global connectivity. These sea cables provide critical data on ocean conditions, climate change, and seismic activity, enabling early warning for earthquakes, tsunamis, and other environmental risks. Behind the scientific contributions, smart cables have a strategic impact on the global economy, on the maritime development, on state sovereignty, and also in national security. Portugal is a strong supporter of smart cable projects, collaborating with international organizations such the International Telecommunication Union, the World Meteorological Organization, and the UNESCO Intergovernmental Oceanographic Commission. By collaborating with international organizations, we drive scientific innovation, strategic maritime development, and disaster prevention, strengthening global efforts towards sustainability and resilience. Today, as with our valued partner, the Joint Task Force Smart Cables, that continues to lead the way in developing a deeper understanding of this system, ensuring its effective operation and maximize the benefits for ocean monitoring and global security. So discussing smart cables is essential for everybody because we investigate how to integrate their data, operate the system, and to develop a deeper technological understanding of the ocean. By improving our knowledge, we can strengthen environmental research, enhancing disaster prevention, and reinforce national security, and of course, with a huge impact on the sovereignty. Portugal, with a vast maritime zone, one of the biggest in Europe in the world, stands to benefit significantly from smart cable technology. So the main question for today is how can we improve our economy, our sovereignty, and security using the smart cables technology? As we all know, Portugal has a strategic interest in discussing smart cable because of its vast maritime zone and resilience on maritime subcommunication infrastructures, and also a strong contribution also for the European security. These sea cables increase national security, economic development, and environmental research, mainly in four key aspects. The first one is the maritime sovereignty, and also Portugal owns a significant portion of the North Atlantic, and the smart cables help to monitorize ocean conditions, reinforcing the sovereignty over our waters. Second is the disaster prevention. We integrate sensors that provide early warning for earthquakes and tsunamis, improving national safety and disaster prevention. Third one is the economic growth, and we know that smart cables support the blue economy, strengthen maritime industries and international connectivity, and will be an important contribution to the development of our economy. And fourth and last, because of the scientific innovation, and Portugal collaborates with the global organizations to study climate change, oceanography, and geophysics using real-time data for these smart cables. Portugal is actively involved in smart cable projects, improving its strategic maritime position to increase ocean monitoring and global connectivity. Here are some initiatives that our Observatory is working and is bringing to the public discussion. First one is the Atlantic Camp project, and I'm quite sure that today we're going to have a discussion about this project. A smart maritime cable that connects mainland Portugal to the Azores and Moreira is scheduled to operate in 26-27 and will enable real-time data collected on seabed conditions, adding to research, climate change, tsunami, and will be also relevant for our sovereignty. The second aspect that we are also working in our observatory is to study the strategic hub for submarine cables, which is of course for Portugal, because Portugal hosts today about 10% and will grow up to 20% of the global submarine fiber optic cables, making crucial point for the international communications. And we all know that we have two major projects. One by the Google is Mover, and the second one is Meta to Africa. These two systems will reinforce Portugal's role in the global connectivity and also reinforce our geopolitical position in the global communication network. And last one, the National Smart Cable Initiative, which is also part of this conference today, because Portugal is working in a new submarine cable system to improve connectivity between interlinked islands in Azores. And this project supports economic growth, maritime security, and advanced scientific research. And Portugal also is important because it's going to be also on the lead on the smart cables technology. And this is why the Observatorium of Digital Ecosystems and Infrastructures, with the collaboration of the GTF Smart Cables, decide to organize today this conference in such a nice and iconic place, the Lisbon Society Geographic. I hope we can take this opportunity to increase our knowledge about the smart cables technology. And of course, and for last, I will like to thank you all the partners, the moderators, the speakers, the staff from the observatory, and facility to engineer José Vargas on my left and Professor Bruce Howe on my right, who made this conference possible. Thank you all for your strong commitment to Portugal and to Observatory, and thank you very much. And now, Bruce, the floor is yours. Thank you.
Thank you. You help me here. Okay. First, as Portugal moves forward, I think there are multiple parallel threads that Portugal and the rest of us need to follow. One is absolutely to get the landing cam in the water working. So that's a really high priority. But at the same time, to be aware of the relationship with the international community, other smart systems, making a smart cable network that belongs to Goose, and then also promoting smart in a very global sense. So I'll be focusing a bit on that. Let's see, is this the best way to? Should I just sit here and? Okay, let's see.
Just go to the slides.
Okay, so let's see. Can you all hear me here?
No, we can hear, but if you don't sit here, the camera will not catch you.
Okay.
So
I'll sit here. That's fine. Okay. Let's see.
Yeah, that's the best.
How do I? Okay. Okay, so this is a slide that Jose put together showing history. I'll start off with a little history and context. So cables have been around a long time, 175 years. And the first ones were telegraph cables, followed by coaxial cables, more for telephone kind of connections. And so connecting empires together, that was the original motivation for long distance cable systems, was connecting the British and French empires. And then finally in 1998 or 1988, the first fiber cables were deployed. And this is what we're living with now. So here's a sample. This is literally the cable that goes across the oceans and connects the world together. So garden hose and a long piece you can flex also easily. So and as you all know from the news, even though over the last centuries cables have been critical infrastructure. Now they are more explicitly so, being called that by the society in general. But over those 175 years, these cables have largely been deaf, dumb, and blind to their environments. So in parallel, not quite over such a long time period, but since 1965 at least, there have been scientific cables put out to host instrumentation and so on. And the first one I'm aware of was 1965 off California. A seismometer was deployed. And then following that, quite a few systems off Japan, dedicated systems. And then in 1996, my predecessor at the University of Hawaii, Fred Dunnebeer, deployed a node plug and play with high power, 3,000 watts and fiber optic, wet-mateable fiber optic connectors on top of O.E.I.D volcano, an active volcano. It survived 6 months, but anyway, it was a first high power node as called in ocean observatory speak. And then in 2003, another system similar was deployed halfway between California and Hawaii, providing plug and play capability and seismic data. And that used one of these old coax cables and it lasted for a few years. Subsequent to that, in the United States, National Science Foundation decided to, instead of reusing old cables, as had been volunteered by the industry, they would be funding dedicated scientific cable observatories in specific regions. And so this was ended up being the Neptune systems off the United States and Canada.
I'm sorry. We have to share with the Zoom, okay?
Oh.
Because otherwise at home we will not see you. Just they are complaining.
Não, por aqui está.
There.
Oh. Escondido.
Okay.
E assim.
And now
Não. Vai dizer.
I think you closed the baby.
Maybe.
Very bad.
Yeah, that one. Yeah.
Sorry. What's the
Yes, okay. Okay,
Thank you.
very good. Okay, so and then Japan starting in 2010 started deploying dedicated scientific but largely dedicated early warning systems, and they have invested probably $1 billion in those systems, and those are operational primarily. The 99% of it is for early warning, which rightly so for Japan. But those are expensive, the dedicated systems. So the idea in 2010 that John Yu proposed was to combine the commercial telecom and the smart or scientific instrumentation together in one system. And that was the birth of smart cables, basically, telecom plus science. And this was a picture from 2010 in one of the reports he wrote for the International Telecommunication Union, showing the monitoring of deep overflow water, let's say Denmark Strait, and so on. It's climatically important. And I'll come back to that. So combine telecom and science for mutual benefit at modest cost. So I try to put this in picture form. So on the left, as a result of those early publications and white papers and so on, ITU, WMO, and UNESCO IOC came together to form the Joint Task Force 4 smart cables in 2012, and we've been working at this since then. Roughly the first 10 years was persuading industry to take notice and become more accepting, and at the same time lay foundations within these UN special agencies, these 3 agencies, to help promote the project. I'm pleased to say that yes, indeed, that collaboration has been very fruitful. We are now classified as an emerging observing network of the global ocean observing system, one of 16 such networks that make up the global ocean observing system. And then, so we're smart cables, we're in Goose, and that includes tsunami warning and so on, and then the subsea cable industry, which is absolutely crucial, because when I say modest cost to us, that means like 10% cost to us, and the 90% is still paid by the industry. And let me, down at the bottom, given again recent thinking, and the observatory is, I'm using the phrase marine domain awareness sort of to include all of those aspects of protecting critical infrastructure. All of this critical infrastructure. The cables clearly are being accepted by all governments as critical infrastructure. And now Goose, for instance, is on the bandwagon wanting to say that the global ocean observing system is a critical infrastructure system. And then that trickles down to the sub networks that make it up and so on. Okay, so this is a summary slide. The mission of the Joint Task Force is to promote the global array for climate, ocean, sea level, earthquakes, and tsunamis. And to do that, create a sustained planetary sensor power and internet network. And again, it's crucial we're sharing this with industry. So they have to be totally on board with this. And there shall be no interference between the 2 systems. So the cables show the existing cables, and you know, in the ideal world in the future, all cables would be smart, but probably not. But and it's not really necessary either, along redundant paths and so on. But there are 1.5 million kilometers of cable out, and between 50 and 100,000 kilometers are being installed each year. So there's lots of opportunity to add smart capability to new systems going in, and picking places of interest. And the 3 sensors we've settled on are bottom temperature, pressure, and seismic motion. Simple, robust, well proven. Data can go immediately into operational systems. And with these sensors and the data, we can know the environment to help protect the cables themselves and the networks. The symbols show various systems at various stages. The small green circle in the Mediterranean is wet demonstration installed in late 23 and delivering data now operationally. And then the 2 other green circles are the Atlantic CAM and the Tam Vanuatu New Caledonia system, both to be installed in 27. As I said, we're an emerging network. We're part of the UN Decade of Ocean Science, and really this, coming from the engineering, my fundamental background is engineering. We're providing power and communication service on the seafloor, open to the water. Basically, we're opening up the cables and providing that service. So these are the 2 systems. The main system's going in 27. The Portuguese system, I need to update that distance to 4,000 kilometers as I understand it now. And maybe Alberto can say whether there be 20 or 21 nodes. And the cost is given there. And critically here, the European Union through their Connecting Europe facility program run by DG Connect has put in 56 million euros into the project. And so Europe is standing up behind smart cables with money. So that's fantastic development. And all those other systems that were on there that, and I will talk about more, do expectly get funding from that European fund as well. And from the CAM budget, basically the smart component is about 15% of the total cost, or €1 million per node. And given these examples of cost per citizen, €2 over 25 years per Portuguese citizen for early warning services is not such a bad deal. And then on the right is a Tam-Tam system connecting New Caledonia and Vanuatu, much more modest. And France is paying for the, it's actually 18 million euros for the science component. That's the entire science project, including science salaries and so on. And importantly, they are getting money from the European Investment Bank and the Asian Development Bank. So that's another very positive indicator that these banks are willing to loan the money to the, in this case, the operator in Vanuatu. Things to remember, these systems have 25-year life. Almost anything you do in the ocean today has timescales of a year, 2 years, maybe 5 years. And requires maintenance and service and high cost of ships or people and so on. These are in for 25 years with basically no one touching it, hopefully. And you know, you're getting the data and it's reliable. So low lifetime cost. And it leverages this industry. This is the only industry that's really used the deep sea floor for the last 175 years. Whether deep sea mining comes up and so on, who knows? But we're leveraging all that experience. And I'll say also that some of you know about optical fiber sensing, and that both of these systems will have extra fibers for testing all these new optical techniques for sensing. Okay, a few other systems that are being considered that were indicated on the first map, 2 through the Arctic Ocean, and several in the North Atlantic. And then, so I think there are a total of six or so being considered. And again, all of those will get European money, they will get national money, and they'll all require commercial money as well. So this is sort of what we expected, is that there'll be a combination of funding sources. I'll talk more about the Antarctic cable and then the one on the top right, and then on the bottom is a second Antarctic cable being proposed by the U.S. National Science Foundation, connecting New Zealand with McMurdo and Scott Base on the continent. So I will go to one example here, but let me first say that you know, our goal is to be a smart cable network of the global ocean observing system, delivering operational data for ocean ocean modeling and climate and the whole thing, and as well as for tsunami warning and the seismic data also will go off to seismic centers for the tsunami purpose, but then also just for geophysics and earthquake purposes. And so we'll, with this kind of thinking, we really want to be able to affect our knowledge of the climate system. And as I see it, ocean models are our best summary of our knowledge of ocean physics and climate physics. And so we have to make sure that our data influence those models. So the next slides address the global and Atlantic what's called Atlantic Meridional Overturning Circulation, AMOC, which is part of this global circulation. So first, the global picture. So this is a different projection that would apply here in the society, but it really shows perhaps it is scaling the oceans so that the area here actually reflects the area of the different ocean basins and so on. And then the color lines show the what's called our best cartoon version of global ocean circulation. Basically, warm salty water from the Mediterranean goes up into the Nordic seas, is cooled, that sinks, flows along the western boundaries down to Antarctica, upwells, and is further cooled and sinks, and then is distributed throughout the world's ocean basins, and ultimately in some unknown way upwells, and the cycle continues. So, and one of the things that's it's very clear that in the North Atlantic, the Atlantic meridional overturning absolutely influences the weather of Europe. The Gulf Stream does warm Europe, and otherwise, if the Gulf Stream is shut off, Europe will get very cold. So there's a lot of concern that might happen if there's too much glacier water, glacier ice melting on Greenland. That'll form a freshwater lens on top of the ocean and stop that circulation. And that's one of these tipping points that's talked about. So you'll see there are projects to study that. And then around Antarctica, also that's where a lot of deep convection happens. But then also you can sort of see there are these rings around Antarctica, and this is the Antarctic circumpolar current. And that sequesters the heat and carbon, and it connects all the ocean basins together. It's the largest current in the world, 4 times stronger than Gulf Stream. And it insulates the Antarctic ice sheets from the warmer water northward. And it represents an integrated response to atmospheric forcing. So it's really important to monitor that current. And right now it's not being monitored. This is a computer simulation showing flow around Antarctica, and it's focusing in on Drake Passage between South America and in this case, King George Island, just off the mainland. And this is where there has been a lot of research done, bottom instrumentation put out in moorings and so on for just a few cases, a few years, to give us what estimates we do have. But the feeling is that smart cables can absolutely help here. And if there were one place in the world put a smart cable, Drake Passage probably would be in it. So, so there's a group put together a little white paper, and this is from that, and they list a suite of sensors. Some of these are the same ones we already proposed, but there's more here, of course. Science always wants more, and in this case, it's probably justified. Most important is at this point here is that Chile has started a feasibility study. The Ministry of Telecom and Information Technology has started that with support from the Latin American Development Bank, a feasibility study. So we'll be interacting with them, and hopefully the conclusion is positive at the end of that, and they'll take the next step of actually getting the project going. Okay, coming back to the North Atlantic, closer to home, and the Atlantic meridional overturning circulation. On the left is the present work going on to try and monitor that overturning circulation. So between Newfoundland, Greenland, and Europe, there are these lines of moorings, bottom instruments, gliders, and so on, attempting to measure what the ocean is doing, and specifically to try and estimate this overturning circulation. On the right side are proposed cables And one of the main ones of interest is TwoSAS. TwoSAS is a Greenland telecom company, and they have said they would be receptive to including smart capability in their cable, assuming funding can be found. Personally, I believe that funding can be found because, well, geopolitics, basically. Greenland has 60,000 people, so it's not going to be a commercial case. So the Danish government will have to fund it, and then using that same European connectivity fund can also contribute to that. So we are interacting now with the OSAP science people to get their buy-in on this and so on. But for scale, the present system costs $30 million per year over 5 years. So that's $6 million a year, and monitoring has to go on indefinitely, basically. So, okay, changing gears here to marine domain awareness. I have this one slide only, but because I expect others to cover this topic in more detail. But in our sensor suite, the most applicable one on this topic would be the seismometers. We have both an accelerometer and an ocean bottom seismometer, very sensitive seismic sensors. These are just example pictures that were presented in Madrid a couple of weeks ago by Captain Azos. And on the left are just the 3 components from a seismometer, X, Y, and Z, and highlighting ship signals. So seismometers basically can act as low frequency hydrophones. And this scale only goes up to 50 hertz. And the seismic sensors in Atlantic Cam will go up to 100 hertz. So, and on the right side are just one I think it's 1 or 2 day period that shows signals from ships, marine mammals, earthquakes, and tide effects. So basically, again, seismometers can act as low frequency hydrophones, and this is relevant for marine domain awareness, monitoring ship traffic, managing your EEZ and surrounding areas. I mentioned also that ocean sound is an essential ocean variable as defined by the Global Ocean Observatory System, just like temperature and pressure. So that being designated an essential ocean variable basically tells countries that they should try and make those measurements and then report on them, obviously. My background is ocean acoustic tomography. So this is using acoustics to infer ocean temperature. And so in this, you have sources and receivers, and here are a whole suite of sensors, receivers that could be applied for tomography. Also, in similar ways, optical fiber sensing will play a role in this. My personal opinion is that's still in a research mode, but has great potential. Okay, so I was asked to say, look even farther into the future, and so these are much more my personal thoughts, and I would suggest that maybe the Azores ring, which is being talked about and will be proposed at some point, perhaps could include some of these ideas. So this is just a little cartoon I've put together here showing how smart cables can evolve from the present. Keep it simple, which we have to do to make it a global system. But in some cases, you want to add sensors or you want to add more capability in special cases, which typically make it more complex and cost more money. So you have to really think hard about following through in all of this. But here we start with the basic premise. We start with telecom cables to share the cost of the fundamental infrastructure of power and communication. And yes, some of the fiber optic sensing can be all done from shore, and so we might as well apply that as appropriate. And then we add the smart nodes and new systems going in with temperature, pressure, and seismic. Okay, then maybe in the next iteration, we include a hydrophone because now that's becoming more important. And frankly, it is one of the most robust sensors around. It's been the one that's been deployed for the longest time, and can provide soundscapes and contribute to the maritime domain awareness. Then the next step would be to add single nodes, plug and play nodes perhaps, or maybe where you have inductive power transfer, or some combination acoustic modem and so on. Basically to in a simple way extend the spatial footprint by having and provide future proofing the system, as they say, or so that you can add new instrumentation to the system. So you want to generalize interface to the cable system that provides power and communication. Alcatel is working with an acoustic modem company to integrate acoustic modems into commercial telecom cables. So that will be provided in the future. So that's one positive step. Okay, and then the next would be much more complicated and expensive. Plug and play nodes with kilowatts of power to charge, for instance, underwater electric vehicles, autonomous undersea vehicles, so that one can, just like on land, you want these charging stations distributed appropriately so that these vehicles can truly extend the spatial footprint of the fixed systems. They can carry more delicate sensors that need more frequent calibration. They can transfer calibration to instruments on the bottom, verify calibration, and so on. And then at the same time, you want to be able to locate those, and they need to be able to navigate relatively precisely. And so these same nodes can support acoustic transmitters to basically form underwater GPS networks for long-range navigation across ocean basins. Okay, technical thing, meshing for power, mobile platforms with sensors. Okay, so there are lots of things moving around in the ocean now. Profilers moving up and down, measuring temperature, salinity, some chemistry and biology. And if we could track those accurately with underwater GPS, you get a lot more information from them. And by connecting everything acoustically, you can navigate, you can communicate, and you can do the tomography to get ocean temperature. Okay, this almost final slide. So I've just listed some opportunities here, or challenges, if you will. So Portugal is leading in smart cables. One needs to capitalize on that and invest in that and continue. Use this as a catalyst, use this particular project as a catalyst for more projects, push the government to do more research, development, and implementation. So obviously, starting with Atlantic Cam, we've got to get that system in and working. I mean, that's the real proof of the concept. And set a structure that can handle that project, but then at the same time handle forward-thinking ideas and evolve for the next steps as well. I list various cable projects here that Portugal should be interacting with to help them move along and promote them as well internationally. And again, the Azores Ring is a good opportunity to do more along these lines. Data policy and governance is absolutely an issue. I'm not going to offer solutions here, but others will. And that will be a topic of discussion over the next couple of years. By the time the systems go in the water, it has to be solved. And there has to be a working data system using the test system off Sicily, using the Alcatel test system that will be installed this year. All the data handling should be completely worked out by the time the switch is turned on for Atlantic Cam. All of this can contribute to marine domain awareness in general and specifically cable protection. We in Portugal leading this can encourage proactive policies around the world and international cooperation in Europe and beyond with these plan systems and setting funding precedents and so on. So with that, I'll conclude enabling ocean and earth observing and basically supporting multi-purpose critical infrastructure. Thank you.
Bruce, thank you very much for your very comprehensive presentation. We are now jumping for the first panel. Bruce will be with us all day, all the afternoon. If you have any questions, just let us know. This PowerPoint presentation going to be in our website, so please feel free to access. If you need something, just let us know. Bruce, thank you very much for your time, for your support. And now I call the moderator for the first panel, Nadia Ribeiro, and we're going to talk about science and society. Nadia, please, thank you very much for yours.
And here's a cable sample if you want to look very closely.
Hello, good afternoon, everyone. I would also like to welcome to our conference on smart cables. Like Luis and Jules have already demonstrated, it's a very important topic, and it's about time that we start having a very ample discussion on this topic, not only because of the relevance they have for telecommunications, but also on the impact they may have on society and science. And that is precisely what we will be discussing on this next panel. I would like to invite Professor Miguel Miranda, Professor Luís Menezes, Engenheiro Alberto Passos, and Engenheiro Fernando Garrido join me on this panel. So I will leave up to the panelists the honors of do a brief introduction on their extensive resumes and experience. So I will start. So not following protocol, I will start on my right side, please.
Okay, good afternoon, everyone. It's a pleasure to be here. It's a pleasure to be here with all of you. So my name is Luís Menezes. I'm a professor in geophysics for long years, and I'm also coordinating the Portuguese committee for the IOC at UNESCO, and also the Portuguese committee for the ocean science. And for quite a few years, I've been following this question of smart cables, having the chance to work very closely with Bruce and of course José, who have been instrumental in the development of those smart cables. And I believe these are really important for what we can get for science. So this is something that we'll be addressing probably this meeting. Thank you.
Good afternoon. Good afternoon to everyone. I would like to thanks for being here.
I'm from my PMA, so my responsibility is the seismic monitoring and more recently also tsunami monitoring. At the IPMA, we operate these monitoring systems. And since long time, we were wishing to have the chance to be able to, in real time, observe what happens in the deep ocean as a natural way to improve our work. And the possibility of this implementation of this smart cable implementation is something that I believe started in 2018, 2019. It has been a long way, and we are wishing to see the way to see the 2027 where everything should be in place.
Okay, I am Miguel Miranda. Is it working? Okay. I was a professor of geophysics up to some time ago, on the time when the cables were not so smart. But I'm working now at the Air Center. That is an international organization also by Portugal, but that direct headquarters in the Azores and direct to the south. And the smart cables are an interesting topic for us. Not only because the Azores ring create new fantastic scientific opportunities, but also because this can be considered, I would say, a first attempt to put the industry working along with science in a productive way. So that's my goal.
Hello, good afternoon, ladies and gentlemen. So my name is Alberto Passos. I'm here in behalf of the IP Telecom. So IP has been awarded by the Portuguese government the implementation of the Atlantic CAM, which will be the new submarine cable system that will connect Portugal mainland to Açores in Madeira, replacing the old one that is now about 25 years old. And as our members of the panel, and that been already said many times, it's a great honor for us because this will be the first smart cable. So this idea, which has been pushed by Professor Howe and a lot of gentlemen that are today here with us, and to O.E.I.D, which I thank so much for this opportunity and for this event. So the smart component, it will be the first cable with smart, which is a concept that has been being developed, and it's an honor for Portugal to be the first one, as it seems, the first big one. We don't know if Time.to will enter in production earlier than our system in Portugal. I strongly believe that it will not. Just to say a few words about Atlantic CAM. So the project is in force since 28 June last year, and things are going pretty well. We have now 25% of the cable manufactured so far. The smart component was presented, the smart pod, the CC, the climate change pod, was presented by Alcatel Submarine Networks this last week or about 2 weeks ago in the sub-optics that took place here in Lisbon. So we have the prototype, we have everything more or less ready. So we don't foresee any delay on the project, even though things can happen, of course. But so far as now, things are running smoothly and pretty well, pretty good. Thank you so much, and I will be most delighted to try to answer any doubt that you might have. Thank you.
Thank you to. Sorry, thank you to you all, and it seems that I apparently forgot to introduce myself. So my name is Adriano. I'm a member of the board at Observatory of Digital Ecosystems and Infrastructures. I'm also a lawyer, a telco lawyer. So please excuse any mistake or misstep that I make. I try to follow up with the engineering part of the topic. I think I've been able to manage it, but let's see how I fare during this discussion. So I'm just doing a brief introduction before going over some of the questions that I have for our panelists, and then I'll probably leave some minutes for the audience and for those that are watching us via Zoom to also ask their questions. So it's a pleasure to welcome all of you to this panel on smart cables. And in an era marked by climate change, ocean uncertainty, and the digital transformation of infrastructure, smart cables represent a rare and timely convergence, the marriage of subsea communications and environmental sensing, as we have already seen in my presentation that is made for use. So these systems embed scientific sensors that measure ocean pressure, temperature, and seafloor motion directly into subsea telecom cables. And the result is we have a scale sensor network that supports both digital connectivity and planetary monitoring, with applications ranging from tsunami early warning to climate science to seafloor tectonics. So, as Alberto was saying, and considering, for example, the Atlantic CAM project, we are no longer speaking about theory, we are now witnessing the implementation of this project. And so, for example, the CAM project, I believe it's a 3,700 kilometer system that connects Lisbon, Moreira, and the Azores.
It will be a little bit longer.
A little bit longer.
Now that we have just finished the final route, sorry. Final route.
Okay. Kudos to that. And it's an investment representing around 150 million.
Yeah.
So it's a lot of investment. And we also saw the project that is being implemented in the Pacific, the Time.to cable project in Vanuatu, which also demonstrates how modular smart technology can serve small island nations with low cost sensing solutions. And we also see innovative work in Portugal's K2D initiative at the Alolink GeoLab, where distributed acoustic sensing is being used to turn entire cable lengths into seismic antenna. So, and meanwhile, we also have international standards catching up. The ITU TG 97.3.2 standard, which was published this year, if I'm not mistaken, offers a technical foundation for the global rollout of smart cables or smart repeaters, and frameworks like the EU NIS 2 and the FAIR directives, as well as the 2025 EU Action Plan, also offer a framework for the deployment of smart cables. And we also have to see, for example, where the new direct consultation on the deployment of undersea cables may also contribute to this discussion. And so, as we can see, in terms of framework and in terms of initiatives, we are seeing a lot of things going on. And in this time, we want to explore the state of smart cable deployment, the strategic frameworks shaping their evolution, and how these systems can meaningfully serve both scientific insight and society resilience. And to kick off our discussion, I have some questions that I would like to ask our panel, of course, and without prejudice of the discussion and taking its own course. But since we have discussed or we have seen in length the projects that are being deployed, President Luis, in your opinion, what are the most promising new approaches to ocean monitoring and data collection that we can expect from these projects?
Okay, so I think every time in science when we have the opportunity to have the different set of measures with the different, in this case, higher resolution, higher frequency, and also long time series, this changes a lot of what we know, and we start to get different insights into many things that we thought we knew and actually we did not know so well. So the opportunity of having these cables doing sustained observations with high frequency for a period up to 25 years, this is going to give us a completely new insight into many processes. So processes close to the seafloor. It will help us, for instance, with the seismometers. It will help us to better relocate earthquakes in our margin, which is important because we normally mainly our stations are on land. The other thing is that it will contribute for early warning. Well, Bruce has said most of the things already, but for early warning, our colleague Luis Matias, who I believe is listening to us, he has done quite a lot of work, the theoretical work in understanding what would be the impact in terms of early warning if we have this system operating. And it's important. As most of you know, we are located close in Portugal. We are located close to the main falls, so seismic areas with tsunami changing potential. They are located at about 300 kilometers from the coast, which means that since the earthquake, the tsunami waves in open sea, they travel at a velocity around 800, 900 kilometers per hour. What it means is that we are talking about things like 20 to half an hour, 20 minutes to half an hour. So any minute counts, and so it's absolutely essential. So this work has already been done. Also concerns monitoring the everything connected with the deep sea. So we can monitor, as Bruce has mentioned, whale sheets and so on in the water layer, which is fundamental at the surface. And we can also look at the pressures, using the pressure and the bottom temperature. We will get new information again with very high resolution on phenomena like sea level change, like any impacts of deep sea currents. So all these events, they will give us a completely new insight into these things. So I'm really very happy that this will happen. And of course, the fact that with these sensors, we can also at least improve the security of cables, which is more and more important nowadays. I'm very confident that this will be a major step for all this. Thank you.
Thank you. So, and picking up on that, Fernando, do you think that these innovative approaches will have influence on the policies that may be designed, for example, most importantly, for environmental changes and how to tackle the environmental issues that we have been experiencing over the last few decades?
Well, certainly, the continuous data that is going to be acquired in real time will be a tremendous improvement in all the monitoring process that we are doing. So, not specifically on the climate, but starting, for instance, on the earthquake phenomena or tsunami phenomena. This real-time continuous data will improve not only the existing tsunami early warning service that is already in place for Portugal and for the Northeast Atlantic that is operated at IPMA headquarters, but also it opens a good window, a positive window, let's say, for earthquake early warnings. That is, well, most of you know that earthquakes cannot be predicted, first of all, but they can be anticipated. And some of the largest earthquakes that we could expect in our region, they occur offshore. The origin is offshore. And if we are able to very early detect them and evaluate them, we can design what we can call an early warning service for mainland, particularly for areas that are more critical. For instance, living on Sines Harbor region, Lisbon, but all the coast. And this is certainly a major improvement that we are foreseeing. Nowadays, the present tsunami early warning service is has some constraint, and of course the major constraint is that we cannot observe what is occurring in the deep ocean. We will have that possibility, so we can gain time, but at the same time, not just gaining time, but also improving the process itself, the forecasting process. And for the earthquake side, nowadays it is possible also to do this early warning process, but the risk of false alarms nowadays is very high. So the system works, but it has too many false alarms. So with a better constraint network that will arise from this smart cable implementation, we will strongly reduce the possibility of having false alarms, and we will improve the what we call the leading time. want to be. So those are some of the major improvements that we expect. And of course, collecting data for ocean circulation, for new science eventually, because temperature, pressure in continuous mode, it's something that we don't have nowadays.
Thank you for that. Professor Moreira, which smart cable projects do you see as setting the new benchmarks for marine science and technology? Also considering what Professor Lisbon and Fernando have explained, which ones will be better equipped in the near future to address all of these issues?
Let me go slightly back. Because this process, I always like to go to the history, to where all this started. And I cannot forget the energy of Professor Carlos Salema from the ID, from the Institute of Telecommunicações, that made the first approach to the geophysical community to say, okay, there is here something new that we must work together. Okay, this was several years ago. And it is very important. This shows the importance sometimes that the cooperation between very different science areas can give, even to anticipate what will appear in the next future. Second point is, will this smart cable approach answer to all our fears and needs? No, it won't, because it has limited capacity of observation on the water column. It is directed to geophysical, geodetic, and at least geochemical monitoring, and it is not enough in the foreseen future. But it is a good starting point. It is a fantastic starting point. Why Portugal is leading this effort? This is another question that sometimes is not understandable from most of the people. Portugal is the only real archipelagic country in Europe. It's the only country that has 3 different regions separated by the ocean, where the only communication is made by optical fiber, finally, and that has in the site a very dangerous geophysical phenomenon, and so it has the best mix to understand the need that we have. If you think, for example, for France, that has also some downtown, the domaine de commerce, but they are not of the same comparable size as Madeira and Azores. Even Spain, that has the Canary Islands. Canary Islands are close to the African mainland. It's a different situation also. Who will gain from this? Unfortunately, Portugal, is in promise, Spain and Morocco, for sure. You'll get as much as Portugal, because from the warming point of view, they are in the same problem that we have, and they will be, I will say, the most direct beneficiaries of what is going on, unless we are able to sell them the forecast. Why do we need absolutely this? Frankly, because we are building high-speed trains. And high-speed trains cannot cope with accelerations that are produced by earthquakes, if those accelerations are big enough. And it is a system that can be easily disconnected automatically, or at least the speed can be slowed down very quickly if we have the information of it. This is why the most important information that is in the CAM and in the other smart cables is early warning. Second point, there is defense. We cannot, at this time, we cannot escape the need to discuss also the needs of the defense people, the needs of the Army, of the Navy, concerning what is going on the ocean. Because the ocean is so hidden, so black, that this is where most of the problems are now. Because in space we are able to see everything, some cases we are going to intercept, but in the ocean it's not the same business. So the mix between the interest of research and the interest of the Navy must be understood from the beginning. even if my opinion that I have already expressed several times is that early warning is the most important information. In the second place, defense information. Then we have biology, biological fluxes. That means big mammals that are always circulating on the ocean, that we can address the possibility to monitor them in a much more systematic way. If we have a line that, for example, crosses the connection between the Mediterranean and the Atlantic, of course, we have capacity to understand in and out fluxes of big mammals. And this is important for the equilibrium of the ocean. So what I can say is that this is an adventure that is possible because our friends from IP Telecom are strong enough to be able to cope with it. That started in the research area, purely in the research area, that was acknowledged immediately by the early warning people. At that time, I was from the early warning people, by the way. And that is acknowledged also nowadays by the defense people, because it is also important for them to cope with that mix. Will it be possible to do everything everywhere with everyone? And my answer is yes, if we are smart enough. It has been done in the past. And frankly, if you see TV today, we are going back to the past very fast. So let's go back in a much more, I would say, structured way.
Alberto, your take on this?
Okay, so let me see. Okay, so basically, I just have to say that I totally agree with my colleagues here. I have also to say that IPMA was crucial when defining the protocols for the smart component. Basically, the 4 components that we will have on the sea bottom. So we'll have about 20, not about exactly 20 CC nodes from change. They will be equipped with 4 sensors. So basically, some of them will be for monitoring the environment, like temperature, gauge meter. Then we have the accelerometer, and also the seismographer. So we will have high frequencies and low frequencies. And so this is in terms of the smart component, because there's a telecommunication component that I will speak in a brief. I've not much to say. It will 6 pairs for telecommunications, each one at 25 terabytes per second. Basically, the original idea was 150 terabytes per second, replacing the actual 3,000 gigabits. So like 500 times more capacity that will be laid down in the bottom to connect Açores and Madeira to Sines and Carcavelos, Portugal continental. With the developments made on between, the cable most probably will be tuned to 160 terabytes per second due to advances in terms of the, not interpretation of the modulation of the codes that will be used. In terms of the smart component, so yes, we do believe that it will be something new, because we have in a permanent way of working, information from 4 sensors, 20 sensors, each one will be sampling at 200 hertz, so it will be 200 samples each second. So this at 24 bits, so this will be not much information. I say 1 gigabit per second, but will be a lot of information. And I believe that if this makes its way, this one will make for sure, I believe, but other comes after, other system, other submarine cable systems come after. This will be a huge improvement. Having information from the sea bottom live, that was the word that I was missing, live, direct, every day, every hour, every second. It is something absolutely unbelievable. I didn't hear much about that in this last Nice that was held last week. I don't know, but I spoke to someone that was there saying Portugal will be on the forehand, is on the forehand of this, and will have a system covering a little bit more than 4,000 kilometers. I didn't say a while ago exactly. So this will be 4,070 kilometers. It will be the exact distance of the system, connecting Sines to Madeira, Madeira to Açores, Açores to Carcavelos. So it will be quite a big array in the middle of the ocean, taking information every day, every hour, every second from all these important, not mentioning the other part that is not will be discussed further on about the defense is just for monitoring. So it will be, I think it will be a great opportunity for the idea is not to show the rest of the world what we can do. Is basically it is what it is. We hope to make this right, and we are taking all the measurements, all the steps that we can consider right now, also together with all these colleagues. Something that we might not think about everything, but with the help of the others working as a team, we add that. So the project is still not reached yet its first third, so it's not 1 year. It's not 1 year has passed since the contract is in due force, and things are going well, are going okay.
So basically, what we can say is that Portugal is effectively setting the trend for what smart cables should be in the future. So we are paving the way. I can say that very loudly.
That's very well said. Paving the way with the help of GTF, smart cables, and all our community, scientific community too. I believe that we will have a good chance to show everybody how this should be done. Absolutely. At least that's what we are working for.
Congratulations.
Thanks so much.
But also considering what Professor Miguel Miranda was saying on, so there's a lot of information going through these cables, and these cables move at great speed, and we need to ensure that they are also resilient in order to be able to benefit from this. And you mentioned that ICMA set the standards. And so what can, besides ICMA setting the standards, are there also in place other policies or instruments that we can consider that are helping in setting the parameters that needs to be taken into account when we deploy smart cables in order to ensure their resilience, to ensure that they effectively can endure some of the hardship that it means to lay cables on the bottom of the ocean.
Okay, well, first of all, I would like to compliment some of the information that we've been given here. So since the beginning of this process, in order to establish the requirements of the sensory parts of the cable, I should remember a consortium that was established in 2018 between Instituto de Técnico Science, Instituto de O.E.I.D from the University of Lisbon, and IPMA, where we volunteered to discuss and have a lot of work to prepare the requirements for the sensory parts and also for the data acquisition processes. So during this process, we were mostly concerned on the specifications of the sensors and on the specifications of the data service that we were expecting. So we put the requirements that needs to be matched by the suppliers, and ASM provides a proposal that was okay on that side. And but the other thing that related on how resilient the cable is going to be. So of course we expect it to be as much resilient as possible, in the sense that this industry of the selling cable is a well-proven industry. So what is manufactured and deployed is for long periods of time of operations. So we don't expect specific problems on that. On the sensor part, it's a little bit more tricky because the manufacturers of the sensors that are going to be used do not provide this expectation in terms of lifetime for the sensors. So there are some difficulties on this, but the knowledge that we have from those sensors when they operate, for instance, make us be very confident on the performance and on the resilience of those systems.
So when we talk about the providers or the manufacturers of sensors, and then we have also discussed the benefits that can be
withdrawn from the tables concerning various sectors, biology, national defense, national security. Prefer to we share. What can we see in terms of, so we have already discussed some examples between cooperation between academia and industry, but should we also consider governance models or technical standards to support a broader adoption and stakeholder engagement and cooperation or collaboration regarding the deployment and then the use of the information that is provided using smart cable technology?
Yes, well, for sure, one of the key things is the data handling and data management. So, thanks to the efforts of IPMA and the Hydrographic Office recently, it was possible to create and Miguel was involved in that, to create the National Oceanographic Data Center, which is about to be announced publicly soon. And this will be a major step. And so one of the ideas is that we can use this facility for data management. As well, we have, so this will be a central database in which you have two main nodes. So we have one node at Hydrographic Office, one node at IPMA. And there is the possibility to bring in new nodes. So this is a distributed system. You can bring in new nodes, but you can also bring smaller nodes, which are called ADUs, which is auxiliary data units. So for instance, a university that wants also to bring in data, they can become an auxiliary data unit. And so this question of data handling, which of course in the beginning it will be not so critical, but very soon when everything is fully operational, we are talking potentially large volumes of data. And therefore, it may be also interesting to involve our FCCM, which is the Foundation for Scientific Calculus, which has very good performance computers and also data storage systems with redundancy as well. And so we need to bring in together these different sectors so that we make this data available to the science community. Of course, again, there will be it will be necessary to see what the data is shared, at what level of detail, because even for security reasons and for defense reasons, maybe not all the data is fully available. I'm sure many of the variables, particularly the temperature, salinity, and so on, and acceleration, they will be available with the rates and the frequency that is more than necessary for what we are doing. But again, there will be data that may be more restricted. But so there has to be a good cooperation between all these entities so that we know what will happen in the future. But of course, data management is something that needs to involve quite a series of actors so that we make sure that the data is shared with everyone, particularly for scientific purposes.
I was under the impression that the question of data sharing was quite actually critical because you have different interests there to balance. So you have the commercial aspect, because there are also commercial interests there. You have then the scientific issues, and then the national defense, and then also the communications because of the interference in communications. So is it critical? Isn't it critical? So we don't get it.
First, let's try not to oversimplify the problems, because it is always a mistake. We must not oversimplify. If we consider, as I consider, that early warning is probably the most important topic of this system, we have a problem with early warning since several decades. Not only here, also in seismology, in tsunami, everywhere. Why? Most of our system was based on the idea that individuals or NGOs or the civil society was enabled to do the same work as the state organizations were able to do. Meaning that, for example, IPMA can locate earthquakes, but nowadays even Google can locate earthquakes. So the situation is becoming fuzzy. Second point, if we have some information that is critical for the life or goods, can we keep it? This is the problem of data custody that some countries address. Say, no, we are going to give some latency, let's say 30 minutes or 30 hours, and we will release only data after this latency period. But with early warning, this is a dangerous game. If, for example, a big high-speed train derails, 250 people are killed and $300 million are lost. And if the information was not released openly, who is responsible for that? So when we are discussing accountability, and as you know, I was at IPA for 12 years, so accountability was a problem every day, from forest fires to earthquakes. We see that up to now, we have no other simple possibility except to give data as fast as possible, as openly as possible. All other strategies have a legal problem. If it is not now, it will be afterwards. Third point, if this is so, what happens to the countries that are keeping their hands on the data for some time? And what is interesting for those that are interested in marine technology and also money is that the only country in the Western world that was able to install a deep sea floor network was Canada. And it was installed with the cooperation of Alcatel. While, for example, all the other attempts made by US or other countries never achieved this level of realization. And who now has the capacity to do such a work? Alcatel. So open data, open science, and open dissemination of data is the most useful approach for the financial point of view, from the safety point of view. In the security point of view, question mark. This is where the details where the devil usually is sitting. We need to work as fast as possible on this kind of problems and to understand how can we have bifurcations of data and feedbacks that can compensate on that. Also understanding that most of the processes that where geophysical people are interested are deeper than the areas where defense is more critical, because all the area where the optical cables are shallow, between Sines or Carcavelos and the deep ocean, are critical. When you get right to 4,000 meter, 5,000 meter, it's not the same level of criticality, but it's where the faults are. So there are some work to be done and some strategy to be designed with the idea that no critical information can be not acknowledged by the people that are affected by it. Because finally, in the last day, this is paid by tax people, by tax money. So we pay by the people that want to sleep well and be safe, understanding that if something arrives, we have the means and the skills to be able to deal with it. So I think this is the only way I understand that we can deal with the problem. But it's not me, it will be him.
And just before you answer, Alberto, and just to compliment, is it that possible to have mutual benefits for the development or deployment of the digital infrastructure and also search science OPAR in tandem?
Yeah, okay, so I can start by that point. Yes, I do believe so. In the development of the Atlantic Camp since the beginning, when it reached to me, it was already so the data for the scientific field and the telecommunication, they're already pair to pair. It was not something that we have to decide, are we going to have this, what are the benefits or the pros and cons. It was since the beginning a chosen data. So it was already established that it would be like that. So in going a little bit before, just to say that in terms of the resilience of the cable. So just to give you some information, in 2010 there was 900,000 kilometers of submarine cables. Today it is expected to have 1.5 million, and by the end of this year will be 1.6 million. In the next 15 years, it's supposed to have another 1.6 million cables laid down the ocean, and at the same time, around 900,000 kilometers of old cables to be decommissioned. This being said, there are about 200 cuts every year, and the figure has been more or less the same, even though the increase in the number of submarine cables on the bottom of the sea. And that is why, sorry, and mainly because two or three things that you were asking a little bit 15 minutes ago, the resilience of the cable. So the cables are better than today. Our cable will be 1.5 meters deep up to 1,500 meters depth of water, even though our ocean, which is good for the resilience, goes down quite abruptly, and before that there will be much solid rock, so it will not be so buried as that, because we have about 50 kilometers at Carcavelos. So basically the line of the horizon, for someone which is not so used to this, when you look to the horizon, it is like 25 miles, so basically 50 kilometers, that's when the goes deep. In Sines, it will be like 15 kilometers. And when that happens, as we know from data from Geographic, almost all cuts are done in shallow waters. So basically we'll have these points of, let's say, more, where the cable is more exposed or more, I missed the word right now, but I think you understand. Whether the problem can happen is 25 kilometers from Sines and 50 kilometers from Carcavelos. After that, will be deep. Our cable will reach 5,800 meters deep. So it will be quite down. And the 20 cc nodes will be, some of them will be at the continental platform, the edge. Most of them will be near Gorinj Ridge. And there will be like, most of them will be connected to the central Cordillera, I missed the word, and then the ridge, and the Gorinj, close to Gorinj. So that's where the most events for the early warnings, which is, my colleague said, is one of the greatest advantages on this type of installation, is the early warning in case of an extreme phenomenon like a earthquake, a tsunami, and the rest is for science. So we have a MOU in place, will not keep the data. So that as it is thought by now, IP telecom will not have the data for ourselves. The data will be handled to the authorities, namely to Putin. And so they will take care of the information, will use the information. The part of the telecommunication, yes, that will be taken by us. The system will be completely separated. There will be an optical fiber portal where the 6 pairs for telecommunications will be ready or available, it's ready, and there will be one pair at the CC portal for the smart component information. And there will also have another optical fiber, just one, for the DAS, for the distributed acoustic system. So these two systems will not only give a lot of information about the seabed, as it will increment the resilience of the cable itself. Because with the OFS, optical fiber sensing, and the DAS, there's a strong upgrade in everything that goes around up to the cable. So because most of, about 90% of the cuts of the cables are attributed to human activity, either if it's intentional or not intentional. Most of the information suggests that it is unintended. It is basically dragging the fish, drag fish, and anchoring. So it's like the 90% is like 40-40 for each one, and the other 10 are like dredging or something like that. So basically, we don't know how these things will evolve with the hybrid menace, with the threats that we are now facing. Let's see. With the DAS, I think that we have an augmented capacity, and also thinking about the frontal, because in land is so critical as in the sea, and it has to be taken care of that.
Thank you very much. Well, our time is up. I don't know if we can take one or two questions from the audience and then one or two from people watching us via Zoom.
I have a question.
Okay.
Well,
Just start.
regarding, it's a quick question regarding the data management.
Are you saying on
data
the-
handling. Oh, I don't know what it's name is. Yeah, I have a quick and small question regarding the data management or data handling. Are you considering, because I know that both IP Telecom and IBMA are this, and even Navy are discussing the data management model. And my question is if you are considering involving other entities such as civil protection, because at the end of the day, civil protection receive the warnings and needs time to spread the warnings among the population. So are you considering involving not the civil protection, but probably the best entity that should be included is the civil planning, National Civil Planning Council? Thank you.
Thank you for this question. Technically, the civil protection system is the, let's say, a major client of the warnings, for instance. But right now, I think in terms of data management discussions, it's more on the technical side first, because of the different communities. I'm sure from the civil protection system, they will say what we want is the product. Okay, so we don't want the data, but we want the products. So we want the early warning. So manage how you can manage yourselves, but provide us the warnings in due time. I think this will be their approach, and they will make, of course, all the efforts to say that the data should be real time available at the operation site. Say on the monitoring side, for instance, as an email, or even in other agencies in our neighbor countries that can be they can benefit from this real time information. I'm sure that the end will manage a way to provide real time data to the entities that are doing real time monitoring, and then there will be the scientific component of the system, of course. And this we can discuss data latency, whatever, some downsampling of the data. But there will be different ways of managing. But I'm sure, and from the civil protection side, they will say, provide us the real-time warnings, provide us the products, and it means that the data must be real-time available at the operations.
Would you like to, I don't know if we have questions from Zoom that we should also. I think there was one question, yes. There was one question from a viewer that I think could be asked to our panelists. Can I see here?
I can read it. Smart submarine cables beginning to incorporate environmental and acoustic sensors capable of detecting seismic activity, marine life, and potential even submarines. Can we reconcile the environment?
How can we reconcile the environmental and scientific benefits of such systems with the strategic need for naval discretion? Are there technical or policy solutions being explored to address this dual use challenge?
I can answer that. Yes, they are.
It's unanimous. José estamos quiet, so everyone is being unanimous. Yes, there are.
Okay, no, of course, but I would like also to make years ago. Because we are talking about cables and cables and cables, people start to understand that, okay, we are invading the marine environment with a huge infrastructure. And I must say that smart cables are the less intrusive infrastructure we can put on the ocean. All the alternatives, like AUVs, gliders, ladders, whatsoever, are much more intrusive, even tags on the animals. At least we are silent, we'll be on the seafloor, sleeping, unless we are awake by some drama. But anyhow, it is much less intrusive than all the other alternatives. And of course, there are security problems. Everyone understands that. Everyone is working together, and we will find good solutions. We have some responsibility because being the first country to organize this, we should also try to be the first clever country organizing smart things.
Thank you very much. So our time is up. Thank you to all the panelists and thank you to all those that were with us for the entire panel. Just a quick conclusion to say that that the discussion that we had here for this last hour confirms that the smart cables aren't just a technological upgrade. They are a strategic enabler for climate resilience, early warning. I think this is the jargon that we are all getting out of this discussion, early warning. And the scientific discovery and digital cooperation. And from Lisbon to Vanuatu, these systems are defining how we view subsea infrastructure. They are not just channels for data, but they are also tools of knowledge and, as we discussed right now, for protection. We are not just before a technological challenge often finance its progress, but we are faced with a challenge that also implies aligning governance and shared vision. And if we get it right, smart cables can become the neural network of the oceans. So thank you very much for contributing for this intellectual discussion and for helping us to move one step closer to a truly connected, observed, and protected planet. And now for the most important information on this closing. Coffee break is on your right. We hope you enjoy and hope to see you after the coffee break as well. Thank you very much.
You're welcome.
Mas já trabalhar em um ano na ok?
Yes. So, in few words, I would like to say that the main proposal of this panel is essentially to promote an interdisciplinary discussion about opportunities and challenges for monitoring cable for sovereignty, security, and deterrency. When we are talking about cables, smart cables, what are we talking about? Cables are responsible for 90% of all communications in the world. But few countries have developed public policies as well as national strategies for monitoring smart cables. Smart cables have different aspects for regular submarine cables because their sensors allow most more rapidly actions in prevention, repairing, and communication of on situations in cases of attacks or disturbance caused by natural phenomena like seismic or earthquakes, etc. So
for helping European member states in solving this problem in terms of consolidated public policies as well as national strategies for monitoring smart cables. European Union has approved it on February 21 of 2025. It's most recently communication for the state members in reality to monitoring smart cables involving all member states. So it's important that the European Union is trying to delineate a common agenda, defining the areas, the responsibilities, and the roles for all of the state members. So to speak a little bit about that, I would like to invite engineer José Barros. He is at my right. Thank you so much for accepting to integrate this panel. I would like also to thank very much to Commandant José Beleza. He is my first left, and Commandant Vitor Pinto Videira at my second left for accepting my invitation. Thank you so much, and good evening for all of you. Thank you so much.
Good afternoon. Let's it's me to starting with. Before I start, I would like to make some history about on this. Let us say almost 7-8 years ago, Anacom, where I was working at that time, Anacom, me and colleagues begin to alert the sector for these security safety issues at that time. Afterwards, we stepped in with the need of sensing the cables, namely the smart cables. And by that time, it was clear for us from the very beginning that the smart cables that objectively serve science and society could also give something additional in terms to increase the resilience of the submarine cables. That was very clear from that time on, and we always were paying attention to this, to that all that time. Don't forget, and make no mistake, the objective of smart cables is serving science and society, but can bring us also additional value. That means we began to think a submarine cable as a dual purpose infrastructure, because beyond telecom could provide additional service to science and the society, as it was explained, but also can give some additional help for sensing the deep sea too. And we were paying attention to all that from the beginning. Please have in mind that telecom submarine cables are a military target in case of a war. They were from the very beginning, much before the First World War. The submarine cable, telegraph cables were being cut by each side. During the First World War, there is plenty of examples on that, and in the Second World War too. A telecom cable is a military target in a war situation, and a smart cable doesn't come to be a military target because to be smart. No, a telecom cable is already a military target, and a smart cable perhaps can bring us some additional protection that a normal telecom cable doesn't have. And that also is a benefit for the smart cables. As I was saying, Anacom was the first entity dealing with this some years ago. Anacom was also the responsible entity to bring this subject to European Union. And now European Union talks about submarine cables, not daily, but very often. And also European Union has produced very, very recently they call it EU Action Plan on Cable Security. And once again, it's nice to recognize that it is very well identified the contribution of smart cables for the resilience, to increase the resilience of the submarine cables. In their approach, they tackle prevention, detection, plus response and recovery, and at the end, deterrence. All of those smart cables can give some contributions, somewhat more than the others, but they can. And it was nice to recognize that on our side, but also that the Observatory of Critical Infrastructures has already produced a paper about how to increase the resilience of submarine cables, telecom submarine cables, and once again, smart cables are identified in some measures. That's all for now, and I would like to hear from my colleagues. Then perhaps you can afterwards promote some dialogue and to have some questions from them.
Thank you so much for your explanation. I would like to invite Commandant José Beleza at my first left to talk a little bit about your academic background and about your experiences in conducting projects in submarine cables or smart cables. Thank you so much. Welcome.
Yeah, thank you very much. Good afternoon, everyone. First of all, I would like to congratulate this observatory for organizing this event. That's undoubtedly, it is a very pertinent event given the current geopolitical situation. So I'm João Beleza Vaz. After 23 years serving on the Navy, I assumed the position in Anacom. I'm the director of the Anacom, but today I'm here not as Anacom director, but I'm here as the president of the Communications Emergency Civil Planning. Okay, and today that's my role here, and Anacom is not represented right now here. Okay, so I have some ideas and insights to share. Do you want to share right now or afterwards?
Yes, you can. I have a question for you. For the early warnings, tsunamis and earthquakes to the populations, what is planned for the implementation of the warning servers? Will SMS be enough?
Okay. Before I answer directly to that question, let me use probably 1 minute to explain what is SPEC, because most of you don't know what SPEC is. Actually, SPEC stands for Communications Emergency Planning Committee, and is under the system that we call Civil Planning System. The National Civil Planning System was created in 2020 and comprised 9 committees and 1 National Civil Planning Council. Okay. The mission of this system is basically coordinates the national effort to organize and prepare the national strategic sectors to actually to be more resilient to upcoming challenges and risks. And the idea is to increase the national resilience to resist and recover from the crisis situation.
Other goals from the system is ensuring the freedom and the continuity of the government activity, and also the security and the well-being of the population. Okay, this is the mission basically of the spec and the system. So recently we assist to the transposition of the EU critical entities resilience directive, which today are driving the commitment of this SPAC. And today we are fully committed in working on the national risk assessments and on a strategy for the resilience of critical entities. This will be followed by the identification of critical infrastructure that we expect at July of 2026. We have all the critical infrastructures identified. To answer directly to your question, today Portugal has a SMS warning system to the population, but SMS system actually is reliable, but not fast. And so today, with this new system, the early warning system, what we need is a fast system to warn in a fast way the population. And this is completely different what the SMS warning system works. And so the idea of having some technology such as cell broadcasts working very in an efficient way with that database that collect all the data from the smart cables is paramount. Otherwise, we receive the data almost in real time, early warning data, and we don't have time enough to warn the population. And so this is the idea of the new system. Let me go back to 2023. In 2023, the government requested to ANACOM and Civil Protection a report regarding the new system, because today we have SMS and they request what are the best systems that Portugal should implement. The ANACOM and the Civil Protection delivered the request, but today we don't have nothing. But I'm sure that with this new government, something is going to happen. Let me clear something. The cell broadcast could be a good solution, but the ideal solution it's not only based on one technology. It should be based on several technology in a hybrid situation. Probably SMS, cell broadcast, and other systems that make sure that in a timely manner reach all the entities and all the populations.
The other question is, what are the challenges in terms of sovereignty, security, and deterrence? Oh, it's interesting because 59% of all cables are managed by big technological companies, especially Google and Meta. To what extent this is a problem in terms of national security and national deterrence?
Okay, from the spec perspective, okay, smart cables fulfills not only the social needs of safety, because we are talking about safety, but also the needs of security, because the smart cables can allowing the monitoring of the maritime activities already secures the own cable and can secure the other cables on the vicinity. But there is something that I would like to add on this question is the fact that Portugal, given its extensive EEZ has important role to play in this new technology that we call smart cable.
Thank you so much. I would like to invite Commandant Vitor Moreira to talk a little bit about your academic background, as well as about your experience in monitoring smart cables, as well as what are the challenges for Portugal in terms of monitoring smart cables for security, sovereignty, and deterrence. Thank you so much and welcome to this time.
Thank you very much, ladies and gentlemen. Good afternoon. My name is Vitor Pinto. I'm the commander of the Portuguese Navy. I'm currently the CIS head in the Navy staff. First of all, I would like, in behalf of the Portuguese Navy, to thank you for the invitation to be present here. We think this is a great opportunity, and this conference is very important regarding the smart cables, security, and our vision for this intervention is regarding the protection of the critical underwater infrastructure. So, considering the importance of the submarine cables, as everyone knows, and as Jose already said, so submarine cables are the backbone of global communications. Saying that, there is a devastating impact if it is interrupted, and it can be considered like military accident. So, in this conjunction, Portugal's strategic position is also very important, since it's the junction point between Europe, Africa, and America. So, roughly, for my data, 10% of international cables cross our waters, and we have several key infrastructures, cable landing zones, namely in Sines, Sesimbra, Seixal, and Carcavelos, Azores, and Moreira. These facts, or just for saying this fact enhances and further reveals the importance that what we are talking here and what we are doing here. Okay? So it's very important to acknowledge that we are a key player in the Atlantic regarding to submarine cables. Regarding to the threats, the landscape right now, as was said in the previous panel, is namely human activities. 74% is fishing or anchoring, and a small minority in other natural disasters or equipment failures. But we have a new dimension that's proven, and we have strategic targets and military targets that are already in pre-conflict or in hybrid warfare implemented, as we saw already in the Baltic. So the Navy have three-pillar vision to enhance the protection of these equipments. So pillar one is advanced monitoring and situational awareness. Already been discussed as well. The smart cables sensorization provide us to detect external impacts and can serve as dual purpose. So having protection for one side, and science, and early warnings on the others. We consider that due to the new technology that is being implemented, we can extend the use of this information, namely with AI-powered systems, providing big data to be analyzed, identifying patterns, and predicting the failures, as well as implementation of a multi-layer monitoring platform that can centralize the supervision of our excision zone and territorial waters with a public service approach, but a platform that integrates and shares with relevant information. As already been discussed here, data governance model is paramount, and it's very important to have this discussion in a near time in order to have a proper way forward. Second pillar that I want to address is the physical protection and resilience. It's one of them is maritime spatial planning. So in order to have dedicated protection corridors that we know, and it has already been said here, we know that shallow waters is the paramount, is the most important part, and deep waters is less important because it's difficult to attack them. So we need to have a priority in the areas. We need to keep specific routes classified, and we need to have some physical measures implemented, namely regarding to system redundancy and in the cables in shallow waters or even on the cable landing zones. In this regard, the Navy and the AMN, Autoridade Marítima Nacional, has several roles, namely as supervise the dry and wet segments, facilitate the repair ship operations, and maintain close watch in all the shipping around the areas. I'd like to emphasize as well the readiness and innovation. So, RED will enable exercise paramount, namely with all the stakeholders. Spec exercise will be very much welcome. And I would like to, in the part of innovation part, I would like to emphasize our reckless exercise. I don't know if you heard it, but it is an annual exercise that we have approximately 28 countries and more than 2,000 people together that test and experiment a large array of equipments, underwater drones, and sensors. So it's being really an honor and pleasure to see the development that this exercise has international. So reckless exercise can be an asset in order to test and evaluate several, not only sensors, but ways to defend and protect these kind of sensors. The last pillar is one of the most important, that is cooperation and information developments. So when we talk about cooperation and collaboration, we cannot talk about only ourselves. It's an international collaboration. So we, as having the centrality of the ocean and the Atlantic Ocean, we have NATO that we need to collaborate, namely the COI network in Marco. We have the European Union and namely with EDA and ENISA partnerships, and the EU, the ITU, in order to correspond our willingness and our governance with our allies. Regarding international coordination, we think that is very important. Our defense ministry strategic initiatives, the threat assessments, and the cooperation with other stakeholders that being set in this table. Finally, I would like to emphasize that our Navy commitment, the Navy commitment is regarding to security and resilience of infrastructures. We are open to all kinds of activities regarding to this part, but mostly we work on sea, and we would like to have a fully and comprehensive governance model in order to have our how can I say, have our competence very well established and very good. Thank you.
Thank you so much. I would like to invite Engineer José Barros to discuss a little bit to what extent Portugal are ready to assume a leadership position in terms of developing the smart cables monitoring system. What are the challenges for Portugal in a leadership position?
It is very challenge for us, for instance, to be and to play an important role as a node of the global observation of the oceans. That I believe we will have an opportunity for the scientific people to step in and to play an important role on that. For mitigate the natural disasters like earthquakes and tsunamis, we'll have a very good tool, and that will help us with the benefit of everybody. Also, as a contribution that was already mentioned, that for the science to have the possibility to have during 25 years having sensors in the same place, giving us the data on real time, that will create a knowledge that we are not used to have, and I do hope that we'll use that knowledge very well. That's I believe it's an obligation to. Also, with smart cables, we won't stop here with Atlantic Cam, and for me, I would like very much to have another opportunity and in a search to have a future system interconnecting not all the islands, but at least the majority of the islands, and to try to have some branches as a smart cable, but also going far away, far than we are now, and perhaps to test other kind of sensors also. Bruce Howe already gave us some hints in this presentation, and I do think that we'll have an opportunity there for commercial sensors and other kind of sensors too. The life we used to manage risks for the cable in terms of the protection of the cables, but now we are also obliged to think about threats of the cables. I should say that we are being prepared for this situation before the war in Ukraine. It's not new. We were already paying attention to this, and we do believe in, unfortunately, is the reality, and we have to pay attention to this. Once again, smart cables can help us. Thank you.
I have another question is, how can conciliate the commercial interests by the big companies and the national issues in terms of security and deterrency?
Well, I think that's the issue. So how can we collect data? And since the beginning, we need to categorize all the data, and some data that which probably will be time sensitive, and this data should flow directly to the civil protection in order to trigger the warnings to the population. And yet some probably defense information that probably the Navy should, if the information shouldn't be time sensitive, and the information needs to be validated by the Navy before release the information. And there are for sure a lot of information that don't have the time sensitive issue, and probably it should be directly to the Geographic office, IPMA, and so on. So I think the key is defining since the beginning which data is sensible in terms of time sensitive, which data to the civil planning or the civil protection, which data should be deliverable to the scientific community, and which data should be validated for the Navy. So we are paving the way, and so probably the first step we will have some errors for sure, but the second tentative probably we will find a way to do it right.
If I may, just two words. Yeah, to know just two words is regulatory framework. That's what I need. We need.
I don't use that kind of word, regulatory, because this is out of scope of regulatory. Probably should be defined in by the government. Okay, probably in a strategic concept, defense strategic concept, define which parameters should be since the beginning defined as defense sensitive, civil or civil protection sensitive, and which information should don't have any classification and go directly to the scientific community.
Engineer,
Can I
please.
try to complement? This Atlantic Camp is a public cable, is a public operator, is the public money 100%. Who are the clients of the smart data? Are public entities. Are IPMA, are Geographic Institute, are the Navy, and others public entities. Easy to solve. I really, as a civilian, I don't see a problem on this. It's public money, it's public, the clients are public entities, you will solve.
Yes, that should be top down instead of bottom up. But that's the problem. We need that government define what it considers being the right position. Okay. Otherwise, it will probably propose something different than the civil protection.
Yeah. Okay.
Free and open data is always, a two-sword side. So it's. You cannot say that free and open data per se is safe for us, and the public also wants safety, right? So security in this kind of third world. So I think it's very important to have in mind that some of this data is not time relevant, so it can be addressed afterwards.
Nothing real.
And needs to be filtered. And not only because we don't work alone, we work with neighbors and allies, and we have a lot of information assets passing in the Atlantic that we can maybe know about or have more information. And but because that open and free information can be used in other ways that may be critical for our allies from foreign countries, not for Portugal as well. So we are in the ecosystem, and we need to be aware of that as well. Okay? So even if it's a public investment and the data is public, the data needs to be taken care of. Yeah.
The other question is, if you need to get together in a multidisciplinary networks of partnerships with different expertise, different wishes and interests and so on, and according to Michael Porter, economist that has published a reporting about advantage for economy, Portuguese economy in 1998. Michael Porter has said Portuguese people has many difficulties to get together in networks of partnerships for cultural reasons, etc. So the question is, how can develop managerial capacity to get together and to negotiate in international partnerships when we are talking and negotiating with enterprises under different legal jurisdictions, because in the United States doesn't ratify the protocol, the international jurisdiction about smart cables, and for other side, we have on interest in economy, public health, and defense. Oh, how can negotiate in international network of partnerships when we are negotiating with different actors? When we have this deficit in terms of together and to manage different interests.
Well, interesting question. I think the problem is not only a Portuguese problem. I think the problem is a NATO problem and the allies problem and the Europe problem. And so I believe that probably probably we need to listen and to talk with some European countries and allies and to adopt some good practice in order to see the way forward. You know what I mean? So I think the solution is not inside, but also outside. Will be pushed by the international community to adopt the best practice. Otherwise, we are pushing inside. Each entity is pushing from for its side. Okay.
Commander.
I think we have to see the common interest. In everything that we want to do in life, we need to find the common interest in order to have the check and balance and to have the protocol established. So even if we think differently, we need to see what unites us, to do all these key stakeholders and to see what's win-win cooperation with everyone. I think it's the only way.
Thank you so much, engineer.
Well, I don't have. I'm not. That's not my cup of tea.
The other question is, despite many African countries centralize a lot of cables, this country has have difficult access to internet. To what extent it's important to consolidate a social responsibility program and an action for access to information in terms of policies and I don't know. I think to what extent it's important and to consolidate an ethical framework that facilitate the access to internet and the data in countries most vulnerable in terms of infrastructures and policy power.
I think this is a commercial problem, and as a commercial problem, I won't say anything because I'm here not as ENACOM, but aspect. But probably José can give some contribution regarding this commercial stuff because at the end of the day, a submarine cable is a huge. It spends a lot of money. It costs a lot of money, and but probably smart cable can help us something. But I think José can help us.
For the time being, the examples we see is that the observation part of the smart cables is funded by the public money. That's the reality for the time being. We do believe that perhaps in the future, a lot of companies and operators are saying all of them are very green, they contribute for everything, sustainability and so on. Why not for them to pay also or to give some contribution for the smart part, let us say, for the observation part? That's perhaps will happen in the future. But just an example, what smart cables will give us is a kind of airbag and a seat belt in terms of to mitigate natural disasters. But when you buy a car, you don't mind about the contribution of the cost of the seat belt and airbag for the total value that you are paying for the car. Who knows within 20 years if the majority of telecom cables will be a dual multi-purpose structure and doing also sensing. Perhaps that will happen. Perhaps the stakeholders will have that on mind, and perhaps for them, if they have also some benefits, they can contribute also to have those cables with sensors too. That's a case. About the data we are getting from a smart cable. Mainly there is data that may have some sensibility in terms of defense that won't be public, that won't be released on real time, for sure. It's obvious. But all the other data will be in the interest of I should say, humanity. That means for science and for the society in terms of early warning. That for early warning, that will have to be released on real time. And IPMA will be the client here. Perhaps IPMA will share that information with the other IPMAs in Spain and France and so on. That's not a commercial data. I don't believe IPMA will be selling that data. That won't be ethical at a minimum. And all the other information perhaps won't be for serving the science won't need to be released on real time, but I do hope that could be storage in Portugal and process it in Portugal as far as we can do it. That should be very interesting if we will have that possibility. Once again, that will be shared internationally with other stakeholders, other public entities, international organizations, and so on. It's up to the others to pick up that information and to use it for the benefit of all. Once again.
Thank you so much. We have some time to questions. I would like to invite you to do some questions for our speakers in the classroom or in Zoom. Oh, please, can you go to the microphone, please? Thank you.
Thank you. It's I commented the question maybe to Moreira about not exactly about the smart cable, but about the use of the service, the use of the products of the smart cable. Cell broadcast is really the best approach to distribute the wireless to the population. I fully agree. So I think Portugal has to go into that direction. But what about also the primary services, for instance, without the emergency service that is given without the framework of the European Commission?
Thank you very much for the questions. Actually, Galileo is on our radar, but first, I think our approach is going to the basic, and the basic is 5G cell broadcast, not on 5G cell broadcast, works on other bands, but cell broadcast, believe me, there's a lot of technical issues implementing the cell broadcast, even with the serial and model of the mobile phones. Some old mobile phones are not prepared to use the cell broadcast, and so the way forward probably should be in a hybrid situation, SMS solution with complementing with the cell broadcast. Using the Galileo is something that we are discussing right now, but that's not a priority right now. Thank you for the question anyway.
Thank you. We have other one in Zoom. Can you check, please?
Yeah, in the chat.
Yes. I don't know. No.
Super light, step out.
Okay.
Only phone, right?
No question. I would like to invite our director, Professor Luis Bernardino, to do a question to the panel. Thank you so much.
Sorry.
That's not so.
Hold on, hold on. Right. There is any question? Ah, okay.
Well, one of the topics that we choose to be discussing today is about security, okay? Because I see the smart cables as an add value for the security and defense of not only the protection of the sea cables, but the protections of our dimensions on the Atlantic. So, and this is a mind change. This is it changed the way that you see the smart cables using to provide security to our dimension in our way that we see the Atlantic. My question to you, and of course, Navy and concerning about the stories, do you see that it's going to be a good contribution for the security and the sovereignty of Portugal, or it's something that is not for the moment? Maybe it's the last one.
I think the maritime situational awareness is made. It's like a system of systems. So for sure, the smart cables can have an added value for a wide range of systems and capabilities. I think that we are in a stage right now that we need to test and experiment, and that's what we do in Raptors, to see what added value we really gather from the smart cable, okay, and from the sensors. And I think that's the major step that we need to do right now. Okay, we have this technology. What can we do with that technology? Because in the theory, it's easy to put it in a light sheet or in a PowerPoint, but in practice, using it, it's where the challenge resides, and that's what we are trying to find out right now.
Just let me complement. Furthermore, as you probably know, Portugal is planning the replacement of a source in the inter-island ring, and probably this replacement will include new submarine technology, and also probably can consider the sensing of the submarine cables. And sensing submarine cables that connects all the islands, it will increment the area that might increment the data and might increment and increase the capacity of the maritime domain awareness.
Yeah, I don't have any doubt that the smart cables will be used in the near future for maritime situation awareness. And there's a big concern about this technology, not only from our side, from our allies as well. And we are in the edge of this. So everyone is watching and is close to see what we can gain from it.
Basically, it extends the capacity of the CAN ring to the western.
One more question.
In my point of view, I think that at this moment we have a huge opportunity to the manufacturing ships. So because we have a big area, so you consider that we have capacities to manufacturing new ships to make the maintenance in our sea area. Thank you very much.
Well, that's a great question, but it's not for me, unfortunately. I think that we Portugal need to, and that's my personal opinion, not the Portuguese Navy, please bear in mind this. We need to address and see the opportunities that we have in front of us. And for sure, we have in front of us, we have the sea, and we need to see the opportunities that the sea brings us. And that's commonly used. If you look at Europe, we are in the far side, western side of Europe, but if you look at the Atlantic Ocean, we are in the middle of it. So our centrality is in at sea, and we need to see and to grab all the opportunities that the sea allows us. That might be one of them.
Well, let me compliment. Azores recently has a ship, hydrographic and oceanographic ship, but at the time it was planned, they didn't consider the facts and the specifications to able the ship to at least repair a submarine cable. This is something that we discussed in Azores. Probably, and considering the new government program that aims to secure the submarine cables, probably why not in the near future?
So I would like to thank very much to engineer José Barros, José João Beleza, and Vitor Videira for your brilliant explanation, as well as all of you that have attended this panel. Thank you so much. I will have informed to all. Thank you so much.
Thanks.
Só uma foto, um minuto. Depois vem só os quadros. Vamos? Ok.
Não estava a não estava
Não, queremos usar esse.
Nós temos que continuar aqui Okay. So, moving now to the last panel. Good afternoon. Moving now to the last panel, we have with us Navy Captain Luís Zucato. As we could see in the previous panels, the panels have corrected smart tables are certificates that score our country and they need to be protected. Therefore, we can identify 3 points to highlight, namely the protection of the infrastructure, data security, and the last one, geopolitical implications, namely controlling smart tables and they can provide significant leverage in international relations and potentially influence global politics and economy. So with us, as I said, we have here our last speaker, Navy Captain Luís Zucato. He is a retired Navy captain with a background in submarines, namely as executive officer, and in submarine squadron, and he is also the commanding officer of 2 frigates of John Bell class. Ashore, at the national level, he developed his background in intelligence teams, namely in the Portuguese Navy Fleet Command and in military operations in the General Staff of the Portuguese Armed Forces, as we know, it's called the CAMP. Later, he was the Navy advisor to the Chief of Defense. He also has extensive multinational and Navy experience, representing Portugal in exercises and working groups in electronic warfare and intelligence matters. He spent 3 years in Norfolk at Allied Command Information as national liaison representative. So he was the chief military representative at NATO in the US. More recently, at the National Office of Security, he was the head of Central Registry and the head of the Classified Information Management and Interpretation Systems. And since May 2022, he has been in the MOD as the director of the Strategic Defense Planning Division in the National Defense Policy Directorate. Please look up to for his yours.
Okay. Thank you. I know that I'm the last one to speak, so it's the most easy part because everything has been said already. So I will try not to repeat too much what was being said. So I will try. I have only 100 slides to show you, so you have to bear with me with the time and patience. So, okay, so it is an honor. I would like to thank you on behalf of Defense Policy Directorate in the MOD invitation. For us, this is a critical issue. I will try to show lots was already being said about national security, data management, science, investigation, money. So I will try to put on our vision, my personal vision, and I will show the agenda. As a matter of fact, as 10 years living underwater, so we are speaking on underwater operations. So I fully understand the pros and cons of smart cables for underwater operator. I worked 10 years on silent service, so silent service, not very known service. With this technology, everything will be known or more known. So that's a shift in the paradigm that we know everything on space, everything on land. So we don't know too much underwater. It will change very fast in the next years. So this is my agenda. I will use some information that I obtained from my friend Alberto in the last meeting. I will mention this on the slide. Okay. I will not read what is in the slide. So somebody already in the previous presentation mentioned that the criticality and our way of life depends on it. So we will get used to live with this facility. The issue is, without that facility, how can we survive? In terms of national security, this is the way around. We need to be or think if by something or by any problem, we don't have access to this technology by any means. It could happen, like some days ago, with the most basic mean that is electricity during several hours. So in this slide, I use this slide that was shown to us on the meeting end of May in Sweden. This was made. This is taken so by a threat assessment briefing by US Navy. So everything is there. Wartime attack, sabotage. I already mentioned. We are in peacetime. We are at war. First of all, let me say that we are at war. Sorry for the majority of people. We are at war. But fortunately, we are not on the physical war. We are at war on hybrid warfare. So everybody, every day, we experience something not visible for the majority. Unfortunately, there are other places in the world that they are really at war and physically they are impacted.
So the risks are more or less very well defined on the right column. So the challenge market, number of cable ships, maintenance, challenging environment. That is also, I will mention more in the presentation on that. Licenses and cabotage laws. An issue that is not here mentioned is the different legal frameworks that in our area, European Union, NATO, Western, Eastern, South and North, and that impacts also in the resolution of some problems and incidents that you'll see in the news what is happening. So this is another slide that more or less was mentioned, that you see at least 200 per year. The majority caused by fishing, already know. So you can see on the cheese the red color. There are some incidents that are very well published in the media. We were exposed on that meeting in May with some northern allies, recently joined the alliance, some poor seamanship or alleged poor seamanship. So that's an issue that is still to be maintained. So our geography, fortunately, is not the same that in the Baltic. So we are different. It was already mentioned by some speakers before. We have to be concerned in the approaches to the landing docks and on our territorial waters. There are some vulnerabilities there. Okay, this information was taken by my friend Alberto, so but I put it here already. What is the cable, internet? Without internet, the majority of the people go berserk. Sorry for that. So I've experienced, I've noticed on that famous apagão some weeks ago, lots of people were disturbed. Our way of life was disturbed. You cannot buy medicines in the pharmacy. People brought stuff from the supermarkets without paying. People were buying stuff that they don't need it without any uncertainty what will happen in the future. So in terms of national security, this is a concern if something fails with on this kind of infrastructure. One thing that I would like to say, national security is a responsibility of everybody. Everybody that is seated there and here is responsible to be concerned regarding national security. As a nation, as an old country, it is a collective responsibility. So everybody has a small or a big share on improve the national security and the national resilience. Some geostrategic factors, so already been said, that is also taken by Alberto, one of the presentations that he made. So we are already a mooring platform. So in terms of geostrategic, geopolitical advantages, of course we have advantages, but we have, if we are becoming more advanced and everybody is looking at us for the use of the smart cable, we have bigger responsibilities. So a coin has two faces. Usually you only look for one face, not for the other face. So the other face is responsibility on protecting the infrastructure and increasing our national security. And the organization where we belong, NATO, and organization where we are, the European Union. So we have more responsibilities than advantages. Okay, that's my firm belief that we must be ready for that. So this will strengthen our position as a gateway with implementation of this technology for sure. Some concerns. Lots has been said on data management, but I think there was one or two people that mentioned data governance. Two different issues. Data management is technical. That's a tactical issue. Data governance is political and strategic issue. They should work together, and data governance gives accountability and responsibility. We don't have yet the data governance. That's an issue, very, and we need to sort it out. We have some ideas, I will try to explain. So business continuity, that's an issue. I know that there are some strategics, so the operators, they know much more than us what they have to do if something happens with the cable, they reroute, whatever. But I've learned that when I will say, I've learned that at least and on average, a repair for a cable is in less 30 days if we are in the Baltic. If you are in the Baltic, where they have lots of ships and availability of ships, but if you are south, probably it's more than 30 days. So geopolitical is everything is about control of cables and leverage. We are one of the biggest countries in the world, as you already know, because we have a big space. Land, sea, land, sea, or land, sea, land, whatever. And we are bigger, so if we have this advantage, we have also this responsibility, and that can be used as leverage if we know how to use it with the right time and the right leverage. Other concerns, state and non-state threat actors. So everybody knows, let's put names on the threats. Russia. That was already mentioned by Professor Barros, that we are not at war, but usually the people prepare before wars if they want to eliminate or destroy physically infrastructure, and this will be one of the first to be destroyed. So be sure that Russia and other allies, thanks God allies, we are on the side, have that capability to map our globally the area, and they have the capability to destroy in case of a bigger conflict happens. Data governance, that's a concern. That's one of the biggest concerns. Why it is it should be a national security concern, because you don't have a data governance for that. As soon as we have data governance, probably the concern will diminish. So the limited number of cables, already said, cable launchers, repair vessels, that's a strategic vulnerability. We don't have our own ship to repair. I know that is very difficult, very expensive. We don't have the knowledge. So mention buying ships, building ships. Building ships is easy. The problem is to put people that know how to operate in the ship. So that is a different issue. That takes a lot of time. So even if I have money to buy ships, I don't have money to contract people because the other pays more than that. So that's an issue that's also a national security concern. And of course, the last one is the most demanding, challenging, because hybrid threat is not only cyber. Cyber is the most known, but there are other hybrid threats that some people forget that they were always used last century. They are being used as of today, but cyber give us another dimension. So nobody mentioned here on the artificial intelligence. And the concern is integrity of data. With intelligence, artificial intelligence, we can say that in the future, if a data center is compromised and they use IA, they can compromise the data, and we can think that we are seeing something that is not really the thing. So integrity of the data and data center is also the big issue. That is the data governance that needs to be taken together with data integrity. Okay, initiative. So I will not mention this. Was mentioned. The last one was the direct communication. 20. So we take. Directed needs. So I think personally that we must, and I can show you why we need to Why we need to do that? We need to very fast to implement in our law the implemented needs directive in our law. We don't have that yet. So this is what is mentioned in the joint communique that was mentioned. I only put and I like the areas that are as myself connected with the security. And the last one is share intelligence, not only with the EU, but of course with all key stakeholders. Intelligence, even with the operators and the civil part, because intelligence can be shared if they need to know. It's a question of planning and work, some work. Okay, initiatives, NATO launched that initiative, everybody knows. Okay, that was IOC last year. Portugal has already, it's a small center that is in Markham in UK. We have a Navy officer, OF4 commander, so he's a voluntary nation contribution and is working for NATO, in sake of NATO, in sake of all the alliance. More recently, we were in end of May in Karlskrona, where there was this issue where the main focus was to share. So the meeting was unclassified. The Portuguese delegation was composed by me as a strategic POC, by Manuel Maias from the Directorate of Maritime Resources, and by one representative from the Portuguese delegation, Alberto Passos from IP Telecom, that brief about the CAM, and from one representative from ANACOM on the security side. It was very interesting to see other perspective, also interesting from the other actors that we managed to go there, because we must involve partners, operators, and industries. What we are doing. So the NATO and the EU, they are doing both. They are concerned with that. The EU has one approach, lots of regulations. Some member states implement immediately, others not so immediately. NATO has a more pragmatic organization, not so many regulations. So it creates a center and create a national net of POCs, strategic level, operational level. We have 4 entities involved: the MOD, General Staff, the system of Homeland Security, and the operational on the maritime side. So this is an informal organization, okay? And we are meeting regularly and sharing information. And now with the IP Telecom and ANACOM, our plans are to amplifying and to formalize more. Very recently, the actual MOD, Minister of Defense, and the former Minister of Defense, same people, same person, tasked us, Defense Policy Directorate, to conduct a work only on defense area, to answer some questions and to pave the way for, and we are working with the Navy, with the Air Force, with the Maritime National Authority on the closed circuit defense area, but our goal is to propose ways to be open by our ministers together with the other areas horizontal in the government. So answers, proposals of operation, as mentioned, the program mentioned the criticality of the cables, submarine cables. That was one of the issues that was raised before the election. So it was the problem. We already identified that. So more to follow. Okay, best practice. So mention, exercise and train, and most likely international national cooperation, and learn with mistakes of the other people in order not for us to do the same mistakes. Okay, recommendation. So the 4th bullet is an issue that I would like to give here as, so smart cables and national security, they are connected. That's a must. Final thoughts. Only working together we can go anywhere. Thank you, and thank them.
So, in this very interesting presentation, it is possible to understand that smart cables play a critical role in global communications and data exchange, but they also pose significant national security concerns, of course. By understanding the risks presented and implementing effective mitigation strategies, nations can work to protect their critical infrastructure and ensure the security of their data. And with this, we finish this panel and we move to our seats and we'll continue with our president of the O.E.I.D. and it was
Thank you for all the presentations and panel discussions. Enlightening to me. I'm very pleased to see proactive discussion concerning security. This is the first time I've heard such direct discussion, which is good. And I do detect the feeling of there's ways to solve these problems. Yeah, moving ahead, and it will take time. But again, I'm optimistic that in the time for deploying the cables, that there will be a resolution that's satisfactory to all the parties. So that's excellent. Let's see. I'm pleased to hear from Alberto that Atlantic Cam is on schedule, plus or minus 6 months or so, 1 year, 2027. Yeah. Okay. And that the Portugal data systems are coming together, the hydrographic office and the O.E.I.D and so on. That's very positive. Again, that's necessary for interacting with the global ocean observing system and the other countries doing smart cables and so on. I guess maybe afterwards we can ask how much discussion is there between Portugal's government and the other governments doing smart cables? So France specifically, or I mean, is a discussion NATO-wide? Well, it sounds like it is.
Yes.
Yeah. Okay.
Yes.
That answers that. Okay, I think that's enough, but I really am pleased with the representation here, and all the different stakeholders being represented in you. So I appreciate that, and thank you.
Bruce, thank you very much. My last words is for thanking those who have been today with us here online. Thank you for the moderators. Thank you for the participants. Thank you for the support for GTF. Thank you for José Barros. Thank you for the Observatorium team here on this room, organizing this event. We want to do more. Okay, we want to be more engaged in the discussion, because we believe that the discussion brings new point of views and new additional comments. We're gonna have this presentation and some PowerPoints and slides available in our website. So please follow our work, follow our website, and we'll be more than happy to share with you all this information. And last comment is, this is a very important issue for us. This is maybe the beginning of a huge discussion that we have to put in place, not only inside this room, but even outside for the huge community. It was also important to have the press today. Bruce has the opportunity to make an interview, and I would like to thank you also, because this is important to get this knowledge to the society, open the idea to the discussion to a bigger audience, and I'm happy to that. So thank you very much. those who have been in line today. Will to keep counting with you all, and I would like to ask you a round of applause for those who participate today. Thank you very much.
Thank you very much. Thank you very much.
Thank you very much.